Okay, this week we are going to start solving rational equations. So last week we added and subtracted rational equations. We're going to use that to actually solve a rational equation. So if you look at your notes, it goes through all the steps that you need to know to solve. And so the first one, factor all denominators. You need to make sure they're simplified, like we did last week. Find the lowest common denominator. Multiply each term in order to cancel out the fractions. That just means you're going to get the common denominator for all the fractions. You're going to simplify and solve for x. The very last step, it says check for extraneous roots. So what that means is if you look at that first problem, there are certain numbers that x cannot equal because of your denominator, because there's an x in the denominator. So for this problem, number one, your x could be anything in the world, 1.2, 5.679, I don't know. But it cannot equal 0. Because you can't divide by 0, right? So any solution where your denominator would equal 0, you have to make sure that that's not part of your answer. And we'll go over that in a couple of these examples, but that's what it's talking about. So let's do the first problem. Most of it's just like last week. We're just adding a little bit more. So let's find a common denominator. Now that 2 is like saying 2 over 1. Anytime you don't have a denominator, it's like saying it's over 1. So I have an x, I have a 1, and I have an x. So my least common denominator is going to be x. I don't have to put that 1 because 1 will go into anything. Okay. So I need all of my fractions to have a denominator of x. So the first fraction is good. Second fraction, I'm going to have to multiply that denominator by x to get x in the denominator. Okay? What I do to the bottom, I have to do to the top. So 2 times x is 2x. Alright, so now I'm going to rewrite this whole equation here with my common denominator. So 5 over x is my first fraction, plus my second fraction I changed to 2x over x equals 6 over x. Okay. So you see how all my denominators are the same? Okay. Since they're all the same, this and this equals this, and they're exactly the same, what we can do is just forget about our denominators now and look at our numerators. 5 plus 2x equals 6, and we can actually solve for x. So our first step is to get a common denominator over all the fractions, and then we can use our numerators to actually solve this. Okay, so I'm going to save the x for last. I'm going to subtract the 5. We're trying to get our x by itself. So 2x equals 6 minus 5 is 1. Okay? The opposite of multiplying by 2 is dividing by 2 to both sides. So x equals 1/2. Once you get your answer, go back to your original problem. Or really, you just have to go back to your least common denominator. Okay? Ask yourself, if you put this answer that you figured out, if you put it in your least common denominator, would you get a 0 in any shape or form? And if I put it in, I don't get 0. So that is my answer. And it'll make more sense once you see a problem that will give you 0. But our answer here is x equals 1/2. Okay, so let's look at number 2. We're trying to get a common denominator, and then we're going to solve for x. And we're going to be doing this all week. So you have, 5 days to do 20 problems. It's not bad at all. There should be no reason why you shouldn't get these done by the end of the week. You'll have a paper today that has about 10 problems, and then you'll have 2 days to do that. And then on Wednesday, you'll do another paper with more practice, and you'll have 2 days to do that. Okay, I'll be back on Friday, and I'll be able to answer any questions you have. But that's what we're doing all week. So you don't have to be working like super fast, but you do need to be working during class, or else you're not going to get it done. And you'll start off the 6 weeks with a 0. Okay, there's no reason for that. So let's look at the second problem. We have 3 over x squared plus x plus 3 over x plus 1 equals 1, or negative 1 over x. Alright, first thing we're going to do is simplify all of our denominators like we did last week. That first fraction will simplify. You have a greatest common factor between those two. Okay? You can take an x out of both of those. So if we take an x out, we're left with x plus 1. Okay, I just took an x out of each term. So I still have an x left here, and if I take an x out of an x, I have 1. Okay, so all of our denominators are simplified now. You need to figure out what your least common denominator would be. So it has to have all the parts from each denominator. It has to have an x, has to have an x plus 1. Okay, this one has an x plus 1. We already have that, so that's fine. We already have an x here. Okay, so our least common denominator would be x plus 1. So we need to make sure all of our fractions have this x plus 1. So the first fraction is good. Second fraction, we're missing an x. Right? So we're going to have to multiply by x to get x plus 1. Alright? What you do to the bottom, you have to do to the top. And I know I'm moving a little bit fast, but this is stuff we've done last week. You got to kind of pick up the pace a little bit. Okay, so 3 times x is 3x, and that's going to be our second fraction. All right, our last fraction, we have an x in the denominator. Okay, in order to get this least common denominator that we figured out, we need an x plus 1. Okay, so we're going to multiply top and bottom by x plus 1. That way it has the x plus 1 in the bottom here. Alright, so we have negative 1 times x plus 1. We're going to have to distribute that negative 1 to each term. Right? So we have negative 1 times x, that's negative x. Negative 1 times 1 is negative 1. Alright, so now all my fractions have the same denominator. If you want to rewrite it with the denominator, you can. You don't have to because they're all going to be the same. Since they're all the same, all we're focused on is the numerator. So we're taking our first fraction, it has a 3 in the top, plus our second fraction, which we found was 3x, equals our last fraction, which is negative x minus 1. Okay, so I use the left side of the space to just get all my fractions to be equal, and then I use the right side to actually solve. And for me, it makes it organized where I know I'm looking at all my fractions here and just moving it over here. You really want to stay organized. You don't want to do all the right work and miss it just because you forgot, oh, well, this is my second fraction and that's my last, something like that. So try to stay organized. Keep it together. And then we're going to solve. So if we solve this for x, we need all of our x's on the same side, right? It doesn't matter if all my x's are on the right or if they're on the left, but they need to be on the same side. So let's just try moving it to the left. I'm going to add my x. You always want to do the opposite. So add x to both sides, and I get 4x over here. And I'm going to bring everything else down. 3 plus 4x equals -1. Okay, now that my x's are on the same side, I'm going to save it for last. Okay, so I'm going to subtract the 3 to both sides. I get 4x equals -4. Divide by 4. So x equals -1. Okay. And that's what you're going to do on every problem. You're going to get the same denominator and then solve for x. Now, once you're done, you need to look back at your least common denominator, okay, and plug in your answer. If you get a 0 from any part of this least common denominator, then it cannot be a solution. You cannot divide by 0, right? So if I plug in -1 in for x, I just get -1. That's fine. But if I plug it into this part, -1 plus 1, that gives me 0, right? These cancel out. That means -1 cannot be a solution. We cannot divide by 0. So since we don't have any other solutions here, and the solution we got doesn't even work, our answer is no solution. Okay, so you're going to have some problems where you have no solution. You're going to have some problems where you have one solution, two solutions. Just depends on the problem. But it's okay to get an answer where none of them work. Okay.